day 2. I'm hopeful day 2 of 2. We will see what happens. Okay, front side of the notes yesterday, it was our hyperbola centered at 0, 0, right? A lot like ellipses, but little differences here and there. Okay. Now we, on the back side, are hyperbolas centered at HK. It just means we've got an HK in everything we do pretty much. As you look at your standard equation, notice they're the same except instead of x squared, it's x minus h squared. Instead of y squared, y minus k squared. The focal axes, instead of being the x-axis and y-axis, are y equals a number and x equals a number. Because, again, it's scooted off the center. It's no longer centered at the origin. So our main axis is going to be different. Foci and vertices. Do those look familiar? They should look a lot like ellipses, right? It's the plus or minus c and a still, but added on to hk. Transverse, conjugate axis, Pythagorean relationship, all the same. Asymptotes. And I know we didn't really use the asymptote formula yesterday, but yesterday it was y equals plus or minus either b over a or a over b x. And that was it. Because the intercept, or the origin, was 0, 0 that it went through. The difference here is that it goes through this HK, and so that has to be included. Because this is writing an equation, is what this is writing. Now, as I said, to be honest, we're not going to do much with an equation because I'm still going to draw the box to help us draw our asymptotes. So, yes?
Well, okay, so x, I don't know if I'm right about this, but if x is supposed to equal h, what's the point of having in your asymptote x minus h? Wouldn't it cancel, or like say if x is 4, then so would
x is a variable. Y and x are your variables in that equation, in the asymptote equation. You'd only be filling in a, b, h, and k.
I always.
There's where you're, yeah.
We fill in a, what was it?
A, b, h, and k. X and y. On the asymptotes, you're writing an equation, and an equation has variables x and y because it's an equation of a line. It's like y equals mx plus b is the form it would end up in. Okay. We also have eccentricity of a hyperbola. Notice the form is the same as the ellipse, right? E equals c over a. And I still go by that. I don't even look at this other one, but that just tells you how to find c. Now, in an ellipse, our eccentricity was a number between 0 and 1, and it talked about how elongated the ellipse was. In a hyperbola, your eccentricity is always bigger than 1 and describes how wide the parabola is. Okay, so that's the differences there. Okay, we've got examples 3, 4, and 5a is my hope. We'll see what can happen. So example 3. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1, and whose conjugate axis has length 8. Okay, so we are writing an equation, yes? What kind of information do you see? Okay. I think this is Carly's favorite part here. I agree. It's the easy part. Let's get the known stuff out of the way right away. Conjugate axis has length 8. And if you look up in the chart, what does it say about conjugate axis? Conjugate axis is 2b. So that means 2b equals 8, and so b equals 4. I agree. Let's get the easy stuff out of the way. What can we identify? Let's go for it. Okay. What else?
We have -2 and 8, which is 10. And since the transverse axis is 2a, we could take that.
Okay.
It's the conjugate axis.
Example 3. Example 3.
I am on example 3. Mine doesn't say
Are you on hyperbolus?
It says major act.
Oh, you're on different page.
Oh my gosh, am I?
She has
You might be
ellipsis.
ahead.
You might be back on ellipsis. That's my guess. Yeah, if you're on ellipsis, you didn't fill out your ellipse notes.
Oh my goodness.
Yeah.
You're gonna want those.
Yeah.
Yeah.
Wait, what?
Yep. You're there. Right there.
You just discovered the T.
Huh?
You just discovered the T.
It's okay.
Fill in your notes.
Well, the downfall of when you guys are virtual, I can't, when you're here in class, I can see that you guys are filling the notes in. The virtual, I don't know right now who out in virtual land is actually with me and who is off having breakfast, napping, So when you guys complain that you're virtual and you don't understand, I struggle with, okay, were you actually here during the lesson or were you not? I don't know.
I'd like to think Gary's is listening.
No, just
Very intentional. Listen.
Okay. Transverse axis is what we're discussing here. Transverse axis has endpoints, -2, -1, and 8, -1, which is off on the other side. Now, with that in mind, what Ross was talking about is those are how far apart. So if you go from -2 to 8, what is the distance between -2 and 8? 10. And so that means our transverse axis has a length of 8. And so we can say 10.
Also, can't we say
I'm not confusing the issue at all today, am I? Woof. Okay. Transverse axis is 2a according to our chart. Ross pointed out that the distance from -2 to 8 is a distance of 10. So 2a equals 10, and thus a equals 5 according to our easy math on
I
that
got
one.
one more thing.
Okay.
Does it have to be a left column?
Levi's questioning left column. What do you guys think?
Yes. Yeah.
I don't know.
Why are we saying left column?
The negative ones are the same. That's how I got it.
Okay, I like it. Yep.
Yeah.
If you look, okay, now let me back up for a moment. No one said the vocabulary word. Transverse axis endpoints. What are these?
H and K. Or, what do you
Vocabulary word. What are the ends of the transverse axis called?
endpoints?
Vertices.
Okay.
Okay, so a key to know is that these endpoints are called vertices. Now, with the idea that they are vertices,
Oh, yeah.
notice the -1s are the same. And I guess you don't even have to know that they're vertices, but the -1s are the same, which makes this a left column problem. I agree.
Yeah, I didn't know you could call those vertices too.
Okay, so, and if nothing else, it's because my -1s are the same. And what is that -1 going to be?
Okay.
That's going to be my K value.
I got it.
Okay. Now, if we talk about writing our equation, we don't have we have A and B. We don't have H and K. If we're talking about writing the equation, yes? So if we don't have H and K, well, I take that back. We have K.
Okay, yeah.
Okay. Thoughts on getting H?
Well, oh.
What happened back?
No, I think I know it.
I know. You just put it into vertices form. Because the vertices is H plus minus A.
Mhm.
We know A. I mean,
So you can figure it out from there?
I think I know a different way.
Okay.
I don't know if it's right.
You just count 5 in once you graph it. Like
Couldn't we also
Yeah,
use the
Simon.
Pythagorean relationship, figure since we have A and B already, if we find out what C is, then already knowing that it's -2 would have to be since it's left column.
That's more work than what I need.
No, A is 5.
I don't need to find C. And in fact, I'm not going to find C on this problem. I could if I want to find my foci, but we can do this without finding foci. And here's what it comes down to, okay, guys? And there's a couple different ways, whether you graph it or whether you don't. And I'll be honest, I'm going to graph it because we need that practice. But negative 2 to 8 is 10 apart, right? So that made our A value 5. So that means if you take either of these points and you count 5 in, you're going to be at your center, which would give us our H and our K that we already have. Now, I do want to graph this because the more we can understand what this graph looks like, the better off we'll be here. So, if you are not liking what I was just talking about, well, let's graph. And I'll try and give you the visual. Okay, Levi's not liking it. So let me give you the visual. I think if I put the visual in front of you, I think you can figure it out. Okay, so we were told our vertices are at negative 2, negative 1, and negative 1. Yes? Negative 2, negative 1, 8, negative 1. Vertices. There's your visual, guys. The distance between these vertices was what? 10. So you now need to count in to find the middle. So that means we're going to count in 1, 2, 3, 4, 5. Or you can count in 1, 2, 3, 4, 5. And that means that is going to be my center, because it's in the middle of the two vertices. Everything is symmetric here, right? And what is that ordered pair I just wrote? Or what is the ordered pair for the center, I guess is what I'm trying to ask. Yeah, 1, 2, 3, negative 1. So 3, negative 1, and that 3, negative 1 is my H and K, which it agrees with the K we already discussed, didn't it? Sorry, I just realized I just wrote right to the right there is where I wrote my center. I wrote HK. Now, we'll write the equation here in a moment. I want to practice finishing this graph. We only got to do one graph yesterday. To be honest, I don't need to do a graph on example 4, so we need to practice a graph to get the idea here. So, there's my center, yes. Counting over this way and this way, right? That's my A value. And that's going over 5 each way. You know what? Maybe I don't want to put those lines in there. Yeah, I'm just going to write as A. We already talked that A is 5. Pick a pencil that won't stink and erase. Gosh. Okay. A takes us out on our, I started to say major axis, which major axis in terms of hyperbolas is transverse axis. What's B do? We're going to use it to make our box the other way then. So if A goes out on our, what we want to call major axis, so the transverse axis, B goes out on the minor axis, so it goes out the other way. Meaning, what is B? B is 4. So I can count from my center,
4 every direction.
not every direction.
It has to be.
My A's already go left and right. So that means in this case, my B's go up 4 and down 4.
So how do you decide that your A's go left and right because of the left column?
Yes.
Okay.
And because we were given our vertices. We were told the vertices, and those are represented by A. Okay. So now, to actually draw this, do you guys remember what I did with my A and B values yesterday? Yeah, you just you're drawing a,
The square thing and do the asymptote, right?
yeah, I drew the box, and my box goes through my A and B points. So it's a much larger box than last time. Whoops.
So you went up and down 4, correct?
Yes. Sorry, my box went a little wonky there in the bottom.
What always ends up looking like a square?
Okay, so the idea, A took me out 5 on the main axis. B took me out 4 the other way. Now I have a box that I made. Through the corners of the box, we draw the asymptotes, the diagonals. They go through the corners of the box, and they should go through the center point. Corners of the box, and through the center point.
Maybe I'm going crazy, but I don't know.
I'm not sure I'd use the word fun either, but you know.
And she's a math teacher.
Okay, where do I actually draw, now that we have our asymptotes, where do we actually draw the hyperbola?
Yeah, you go through the vertices and keep doing the asymptote.
Okay. Yes, virtual?
Never cross
As long as it's not too far off. I mean, and I get it. I can totally respect the not being a very good artist because that's, you know, that is me. And that's where, close but not quite there. I mean, as long as it's pretty close and going through the corners and I can tell that the intention was there, I'll be okay with it. Okay. Does your hyperbola look similar to mine? That's what Taylor and I were just talking about, that, you know, the idea is I need those asymptotes going through the center and the corner of the boxes. Make the effort to make it look like that, right? Okay, and I'll be looking for, can I tell intent? If it's way off and it looks like there was no intent, that you didn't realize your lines need to go through the box, I'll have a problem on a test. If it's just slightly off and it looks like the intent was there, I'll be fine.
Sometimes when I draw my talents, like all my X and Y's, like my axis, I draw them a little too far apart, so my ovals look like circles and my rectangles look like squares. So I don't code like that.
Okay, we've got one last thing to do, which was the whole point of this problem, was to write the equation, right? I wanted to practice drawing and see how we could find the center. We said left column, correct? So x minus h squared over a squared minus y minus k squared over b squared equals 1. Excuse me. We have all that information, right?
Yes.
X minus 3 quantity squared over a squared.
We just write 25.
You can write 25. Minus, it's hyperbola, so it's minus y minus
Negative 1, so plus 1 squared.
y minus negative 1, so y plus 1 squared over b squared, 16, equals 1.
So either way, if we wrote 5 squared, we would still kind of right?
Yeah, probably.
Okay.
The question was, if you left it as 5 squared and 4 squared, would I count it right? And I probably would.
Yeah.
I mean, it's equivalent.
I want to say that like 25.
Okay, you guys got what you need there. Okay.
Much fun when you got
Example 4. Find the center, vertices, and foci of the given hyperbola.
we have an equation.
Nice, neat standard equation there. That's good news.
We have our A, B.
We have our A and B.
Yes.
Okay, we're going to have our H and K. Okay,
You guys listen.
yeah, we're going to talk about Ross's A and B values because I don't like them. But just saying.
You said 7.
Like the first time.
Okay.
A would have to be the bigger number still, right?
Yeah. Oh, wait, no. Not for,
Okay,
not for
so-
formulas.
Is this a left column or right column problem? Left column, yes?
Because X has to come first.
Because X comes first because X is positive.
Yeah.
Okay, so with that minus in the middle, this is a left column problem. And so this is of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, we already fell victim in the classroom.
So, can the A's and B's be reversed or something?
Okay,
Did he say it?
A just doesn't have to be the largest number.
Right, okay, so
Oh, did he
hold
say
this
it
thought.
backwards?
Okay, so hold this thought. Let's write down all the information we can. So as we look at this, let me start by getting H and K. H is always, no matter what, paired up with which variable? X. So if this says X plus 2, H is negative 2. K is always, no matter what, paired up with Y.
Okay, it's fine.
Since this says Y minus 5, K is positive 5. Now, the virtual, I don't know what you guys are thinking out there, but my in-class people already fell trap to what's A and what's B. Where do we find A in a hyperbola? Always under the
X.
first fraction. So in this case, it's under the X because X is positive. So if under my X is 9, that's A squared. So A is 3.
And then B is 7.
B is always under the second fraction, so the fraction that's being subtracted. So if that's a 49, B is 7. Okay, guys, I'll repeat it. In an ellipse, what we did last week, A is always bigger. In a hyperbola, A always comes under the positive first fraction. It's not necessarily bigger. And so this was the in-class presentation of, let's get this mess up out of our way now, so we don't mess it up in homework, right? Are we okay with that now?
Yes.
Okay. If we want to go ahead and get it out of the way, what else are we going to have to know when we're trying to find center, vertices, and foci? C? How do we find C? Pythagorean relationship, which is what with a hyperbola?
C squared. B squared.
Okay, C squared equals A squared plus B squared.
Already know what this is.
So C squared is
C squared.
9 plus 49. 9 plus 49 is 58. So what's C? Square root of 58. Whatever lovely number that is.
7.62 approximately.
What was it?
7.62 approximately.
Okay. And I would have said 7 something. I could have gotten you that far. So, and here's the deal. Are we going to have to graph this to figure anything out?
No.
Were we asked to graph it?
No.
No. So, we're not going to have to know the decimal here. Okay. You have all the information to finish this problem. I would like to think it's not going to be too bad from here, but... Okay. Center. What is my center? HK. And I started to say, what is it in the chart? But it says hyperbolas with center HK. So what is my ordered pair here?
-2.
-2, 5. Okay. Vertices. What do I use to find my vertices?
H plus or minus A comma K.
Okay, this is a left column because x came first. So we're adding and subtracting to the x value that is, h plus or minus a, comma k. So put the numbers in. -2 plus or minus 3, comma 5. Did I do my math? Did I write the correct numbers in?
Yes.
Okay. Don't stop here. What's -2 plus 3?
1.
So 1, comma 5. What's -2 minus 3? -5, comma 5. Okay, that's vertices. I'm going to jump over to the right-hand side of my paper. Foci are just as easy, right? What's foci according to my chart? H plus or minus C, comma K. -2 plus or minus square root of 58, comma 5. And yes, you can leave it like that. The only way I would say you need to figure out what that decimal is to give me decimal answers is if we were graphing it. Because I don't know what -2 plus square root of 58 looks like on a graph unless I figure out the decimals and actually do the math. But this didn't ask us to graph it. I mean, we could graph it, but I can also use our time other places. So, and it wouldn't hurt us to graph it, honestly, but I also, if I'm going to try and get a 5A done, I need some time. Oh, we're going to be graphing it on 5A, so that'll give us another practice graphing. Okay. Questions before I flip?
No. What's the practice?
Okay, guys. You and I both know this hyperbola section has very closely followed the ellipse section. So what was example 5 in ellipses? Where we have to show that it was an ellipse. So what is example 5 here in hyperbolas? Yeah, we're going to have to show it's hyperbola. We're going to have to complete the square, put it in that form. We're going to find the vertices, foci, eccentricity, and we have to find asymptotes this time. But before we can do any of this, we need an equation in standard form. Well, they didn't give us much of anything here, did they?
Other than numbers and letters.
Okay. Now, recall what I did with the ellipses at the time. I said, okay, I'm going to group my x's, I'm going to group my y's, then we're going to move any numbers to the right of the equal sign. And because my brain works alphabetically, I did x's and y's, and if A was larger, we flipped them later. Wherever A was. Now, in this case, one of your squared values should be a positive, the other should always be a negative, because they're hyperbolas, yes? So, instead of me saying x's then y's, I'm going to say the positive squared variable first, and group those, and then the negative squared variable, and group those second. Meaning, you might do x's and y's on one, you might do y's and x's on the next. Am I making sense? Maybe, maybe not. Hopefully my actions will make sense here. Let's go with that.
So you're probably going to do y squared first.
Probably already going to be set up like that anyway, because y squared.
It is positive.
Right. I mean, unless they put a negative squared first.
Yeah.
Right. Okay, so this case, I have y squared is positive, 3x squared is negative. So that means I'm going to choose to group my y's first, which means I'm going to have y squared plus 6y. I'm going to leave a gap. Although, in all honesty, we're going to have to do another step yet. Then I'm going to pair my x's because my x squared is a negative. So I'm going to say minus 3x squared plus 6x. I'm going to leave a gap. Do I have any numbers to move to the right? I don't. And 18 is already on the right. Okay. This is familiar, right? This isn't your first time through it this time. Last time it was a big challenge. This time, medium challenge. Okay. What has to be true when we go to complete the square? Yeah. Okay, when we go to complete the square. Yeah, I can tell she knows where she's going with it. We need, on both the x's and y's, for it to be 1. So a 1x squared, a 1y squared. Now, that means my y's, they're already good. We're ready to complete the square with y's. My x's, we are not. So we're going to do another line before we complete the square. I'm going to say y squared plus 6y. Still leaving that blank. How do I get my x squared to be a 1x squared? Okay, except I'm not going to use the word divide. We're going to factor. And notice, it's not just the 3 I'm factoring. I'm going to factor out a negative 3. Nope.
Negative 3.
A negative 3. We need x squared plus bx for the form. So we're factoring out negative 3. Now, let me comment. If there was no number here, but there was still the negative, you would need to factor out the negative before you complete the square. Even if that means just a negative 1 in a certain problem. You need to factor that out. Okay? So, when we factor out negative 3, I'm going to be left with x squared minus 2x. Because we are dividing by negative 3. Positive 6 divided by negative 3 makes it negative 2x. So that middle sign is going to change in the second setup. I left a gap, ended my parentheses, and set it equal to 18. Okay. We ready? How do we complete the square? B over 2 squared. So, in y's, what is b? 6. 6 divided by 2. 3. 3 squared? 9. What do I do? Add 9. If I add 9 here on the left, I add 9 here on the right. And because this is just a plain old y squared plus 6y, it's just a plain 9 we're adding on both sides. Okay. In my x's, what is b? B is negative 2, correct. You have to use the factored version. So negative 2 divided by 2, negative 1. Negative 1 squared, plus 1. So I'm going to add 1 here in my parentheses. If we add 1 on the left, good. We're going to add 1, but this 1 is not just a 1. This 1 is being multiplied by negative 3. So we're adding a 1 times negative 3 in this case. I take it that went as you expected? I haven't heard arguments here. Okay. After you complete the square, your next step is always to factor. Square root of y squared is y. Square root of 9. 3. My middle sign is a plus on the 6, so we're going to have plus 3. The minus 3 just continues along. And then parentheses squared. Square root of x squared is x, square root of 1, 1. Middle sign is a minus. Equals,
X minus 1.
I try to be as quick as possible, but
if I'm quick enough, I can save it. I'm not always quick enough, though. Okay. What did your right side clean up to be? 20 what? 24? Because it ends up being 18 plus 9, which is 24.
Nice. We have like one more step.
Okay. How do I get this in standard form? Divide by 24. Now, I will tell you folks, we're not doing B. We're not doing C.
you actually good for it.
Well, they're basically the same.
Because they take too long. Okay, so, if I do this, y plus 3 squared minus, what do you know about 3 over 24? It's 1/8, so minus x minus 1 squared over 8 equals
1.
1.
We did it.
Now we have it there.
The overseas profiles asymptotic.
There you go.
Just to find everything in the graph.
Okay. Now it is find all the stuff we need, yes? Officially, I wanted to graph it. We may, I don't even know if well, you guys know the gist of where we're going with this, because it looks like I'm going to run out of time. Let's go ahead and identify.
If you are not going to finish, can you tell the results, please?
Yes. Okay, we're going to start at least. H. What's H?
Minus negative 1.
Minus negative 1.
So,
It's just 1.
H is going to be 1.
Fonzie, you're kind of right.
I made a mistake. This one.
Okay, it's the opposite. Yep, you just got all your answers wrong. Sorry. Okay, H always goes with the X. X is X minus 1, so we use positive 1. Sorry about your luck there. K. What's K? Negative 3. Because it's Y plus 3, so opposite sign. K is negative 3. Okay. What about A?
It's the one under. It's the first one, so.
Always the first one. So A is square root of 24. And you could simplify that to be 2 square root of 6.
Wait, so we didn't use it.
You can live without it too. Okay. What's B? Square root of 8. It's the second one. If you simplify that, that becomes 2 square root of 2. Again, you can work with or without it. And we need to find C. Pythagorean relationship. C squared equals A squared plus B squared. So,
Here we go.
C squared equals
24
24 plus
plus 8.
8. 24 plus 8 is 32. So,
22.
C is the square root of 32, which is also 4 square root of 2.
Do we need to do that?
You would not necessarily have to. Okay. What do we need?
We need vertices. What do we have for asymptotes?
Okay, we never talked. Vertices. Which column problem is this? Y comes first. So this is a right column, or Y is the positive. So if this is right column, when I do my vertices, that A is going to add and subtract to the Y value. So H comma K plus or minus A, which 1, comma, -3 plus or minus square root of 24 will work. I'll tell you, I think the answer key answers might be simplified. So the answer key might say 1, -3 plus or minus 2 square root of 6, but I can handle it either way. Okay. Yes, you do have homework today. Now, bell's going to ring. I got vertices. You also need to find foci, asymptotes, and eccentricity. I was also going to try and graph this. I'm out of time at this point. So, here's what I'm saying. Hear me. Yes, attempt the homework for tomorrow. Got it? Complete the homework to the best of your ability for tomorrow.
Do it like it's due tomorrow.
Do it. Do tomorrow. I will help clear up questions tomorrow. Remember, omit 34 means skip 34. I forget why, but I think it just was not a fun problem. Other than that, have a good day.
Have a good day.
Thank you, you too. Yes, I probably need to do that before I end the class, don't I? Thank you.
Oh, nice. So you had to get 70, and I got 69 on it. So then I had to do one assessment.
So that take you all of last period then?
Yeah, I finished earlier, but he didn't want to let us finish.
Just curious, Maggie never came to second hour, so I figured it was something like that.
Yeah. Oh my.
I mean, it's not like Maggie would skip, so I assumed you guys were still.
Yeah. Okay. He comes in.
I think she was
testing. Since you guys are going to do the repairs.
That would sound like Maggie.
And guess who's in charge?
Why are you putting a wing on it?
I got a 60.
I don't know. Yeah. I do whatever the customer told me to do.
That's totally dumb.
It's a four-wheel drive car. It doesn't need it.
Put it on the hood.
It wasn't like in the smart window.
Can I use the restroom?
You can put it on the hood.
It's just this massive price.
Where'd it go?
How'd it go?
Oh.
They're just making it work.
That's what I was thinking.
I could.
You should have done first.
Huh?
You should have done first.
I kind of want to, but I want to get like hits the road. I'm out of here.
You're like, oh, I actually grabbed my grandpa's jacket by accident.
Why?
Gerber quadratic form.
I'm kind of mad that normally I type this on quadratic formulas. And I came across this in my files the other day. I was like, no, I forgot to use it. What is fucking
I don't know how I feel about it. Like, on one side it's funny, but the other part, like, if I laugh at it, part of me dies.
Okay, but aren't a lot of those like this? I mean,
But this is even worse.
this is worse.
No, I mean, I don't know, man. It's kind of tough to beat in the document.
I think it's funny.
It's funny, but it's not as soul crushing.
And this is where everyone's sense of humor is different too. So there's some that we laugh and some that we're like, yeah.
There's certain levels I must not stoop to. This is below that.
It'll be like
It's a
that.
mindset.
Please tell me this is not a bad thing that I have so many empty seats. Are there still testing going on? Okay. I was like, man, don't tell me I missed something. I'm excited to start to get people back. I don't. Okay, guys, you need your notes out.
But I assume you want something.
I need to work on attendance. It appears it's going to take me a moment. That's the kind of stuff I do.
No. It's the way you start. It's the way you start it. You say, and then you said, so you said, I don't have a problem with it.
I'm so happy that our one was not in today.
Oh, it's been fun.
It's been fun.
Yeah, just fun.
It's not been good.
Last night, we got the 2 nights.
Okay, here's what I'm going to say, guys. While I get attendance and figure out all these gaps, if you did not finish example 4C, work on that for me. And you are welcome to go ahead and try 5A if you haven't and would like to. Yes. Use your passing period, though. That's what it's for. Okay, you said Jaden is here. I'm guessing the testing is close to done since some of you are done, and he'll probably show up this period.
I don't know.
Yeah. I think he only had to take
One of them like takes a solid hour.
There's one of them?
And he has to take 2 of them.
Okay. So that's where Jaden is. Peyton made it. Carly's on her way. Okay. What about Kylie Tharp? Okay, that's I saw the list this morning, but I can't remember. Yeah, I ran into her face to face before school, but I know she was in our class. So okay. So I think the only person absent. Do I have Dayton and Olivia? I have Dayton and Olivia. The only person truly absent then is Kylie. Okay. The other is getting. Leave it to the brother to start that. Really? Peyton, you were marked absent last period. Well, now I will say, in your second hour of speech defense, the email from Mr. Hallenstein this morning did not indicate you guys would go past homeroom. The email just indicated that have them check in at homeroom and then excuse them from homeroom. It didn't say, hey, we're not going to get, you may or, I don't know when you'll get these kids back in class, so.
I think that might have been also because he didn't even write that email, but yeah, so.
But I don't even want to know.
I don't know. Maybe he told Doc wrong. Maybe. I don't know.
I would think he would have just had Doc type up the names and copied the names into it, but okay, who knows?